Hey, what is up, AP Calculus? Today we're looking at 4.2 implicit differentiation. So what implicit differentiation is deriving when we have more than one variable. So maybe we just don't have an x in there. We're deriving with x and y, or x and y and z. So the thing to remember is that when you do the derivative with any other variable other than the variable we're doing it with respect to, like in this case we're talking about derivative with respect to x. Let's say we have a y in there. Anytime we derive that y with respect to x, then we need to do dy dx. So it needs to chain, right? And the reason we chain it is because we don't know what our derivative with respect to x is, because our term there doesn't have an x in it. So we just need to make sure that we add that chain on. And once you get used to it, then it's not too bad. You just got to be very careful and remember that we're going to do that every time we have a variable other than the one we're trying to derive with respect to. All right, so let's switch this color here. And let's go ahead and find derivative of y with respect to x of y squared equals x. So, well, the derivative of x is equal to 1, right? So, actually, let's go back here. So we're going to do the derivative with respect to x of y squared equals derivative of with respect to x of x. All right, so I'm just showing that we're doing the derivative on both sides. Now, we just said that the derivative with respect to x of x is going to be 1. Now, the derivative with respect to x of y, we don't know, but let's derive the y. So we're going to get 2y. And then we're going to say, well, we don't know what y is, so we can't just say it's going to be 2y. The variable is not an x, so what we're going to do here is we're going to say dy dx. So whatever our inside was, if we think of the chain rule, then the dy dx will take care of anything that would be the inside function, if there is an inside function. All right, so in this step, we're going to do, derivative of the y term. But also, anytime you do the derivative of that, we're going to multiply dy dx. Okay, so that's step 1. Now, in step 2, what we're going to do is we're going to solve for dy dx, and this is kind of elegant, so we just got to get rid of our 2y, so let's divide by 2y, those cancel, and we get dy dx equals 1 over 2y. And then notice that it's asking us to find dy dx. Well, that is dy dx. We solved it algebraically. Okay, so 1 over 2y. Okay, so again, we're going to derive everything we can. If we derive something other than an x, we got to just tack on that dy dx to it, or dz dx, whatever our variable is other than x. And then we're going to solve for that dy dx or dz dx or whatever they're saying to do. All right, so it says find slope of circle x squared plus y squared equals 25 at 3, negative 4. All right, so we know that when it says slope, that means we're looking for derivative, right? So, okay, we're going to do derivative with respect to x of x squared plus y squared equals 25. Now let's put this stuff in. We have, or let's derive it. So x squared is 2x. Y squared is 2y, but because we derived the y with respect to x and we don't know what that looks like, we have to say dy dx. And then 25, derivative of 25 is 0. Okay, step 2, we said we're going to try to solve this for dy dx, so we're going to have to subtract our 2x. And then divide by our 2y. And I guess the 2's can cancel, right? So dy dx equals negative x over y. Now at this point, this will give us our slope at any x. So we have our point. We're going to substitute our x and our y into our equation for the derivative. So we have negative 3 over negative 4, which is 3/4. Okay, so not too bad. Again, let's recap this. We did our derivative here. We remember to do dy dx anytime we do the derivative of a y with respect to x, right? Then we solved. For the derivative of y with respect to x, which was this. Right, and then because it's asking us to find the slope and it's giving us our point, then we found slope by substitution. Okay, last one. This one says, show the slope of dy dx is defined on every point of 2y equals x squared plus sine y. So this one goes back to that idea of differentiation or differentiability implies continuity, right? Because it says is defined. So if it's continuous, every point is going to be defined. All right, so what we're going to do is we're going to do the derivative of this with respect to x. So the derivative of the first part is going to be 2. Derivative of y is 1, but we still have to do dy dx, right, for that because we derived y with respect to x. The second part, x squared is going to be 2x. We don't need to add anything to that, right, because we're deriving with respect to x. We don't have to do any chain rule on that. But the last one is going to be cosine y dy dx. And again, it's because we have the y as our variable, not our x. All right, so what we're going to do here is we're going to go ahead and move our dy dx's to the same side. So I'm going to subtract this. Just applying our algebra, right? So we subtract it. We have 2 dy dx minus cosine y dy dx equals 2x. Now, because this one has 2 dy dx's, we want to move them to the same side. We're going to factor that out now. And then we're just going to divide by our 2 minus cosine y. That's gone, that's gone. So the derivative of y with respect to x is this thing. We didn't get to the end yet, though. It says to show, right? So we have to explain how we know from at this point that it's defined on the whole, on every point. So let's think about cosine. What do we know about cosine from trig? Well, we know that the cosine can be at most 1 or at least -1. Right, so is there any value that we can have for this thing that's going to make the denominator 0? Well, no, right? Because even if I put a 1 in there, 2 minus 1 is 1. If I put a -1 in there, 2 minus -1 is 3. The only thing that the cosine could be to make that denominator equal to 0 is 2, but cosine never reaches 2. All right, so we can say the function, or the slope, sorry, is defined because cosine y cannot be equal to 2. All right, so that's it. We're gonna spend some more time doing this implicit differentiation stuff next time. So just take this time right now to get your feet wet, kind of get comfortable with the idea of it, and mostly just understanding that anytime we are deriving with respect to a different variable, we need to add on that chain part where it says dy dx or whatever your variable is that's not the x. All right, good job.